to briefly go over experimental setup and experimental design with you. Your first question will be about an experiment, and they're going to give you data, and they're going to give you information, and they're going to ask you to analyze. They could ask you for the independent variable, okay? And the independent variable is always going to be whatever the scientist manipulates. Okay, and you need to write all of this down so that you have it in front of you, because if that's what they're asking for, that's what you want to know. So whatever the scientist is changing, if you're doing the lab, whatever you change, that is your independent variable. Because of that variable, you want to see the effect that it has. So whatever you are measuring or observing in your experiment, that is your dependent variable. So if you're changing the pH, if you're changing the temperature, if you're changing the amount of food, okay, whatever you are doing, whatever manipulation you are doing, the thing that happens because of it, how long it lives, how tall it grows, how much carbon dioxide it makes, whatever you're measuring is your dependent variable. Okay? The key here is we only want to have one. We only want one independent variable changing up our situation, because then we know that is what causes our dependent variable. And because of that, it's very important that you change one independent variable, but everything else the same. And the reason we want to keep it the same is because we want to make sure that the only thing that is affecting our ultimate results is that independent variable. Okay, so when we keep everything the same, we call all of those constants. Okay, so when we do an experiment, all of the experimental factors need to stay the same. So if our independent variable is different temperatures, okay, then that means we're going to change the temperature and make it different for all of the things that we're testing. But because the temperature is the only thing, just one thing we want to change, if we're doing it to plants, we want the same species of plant, we want the same light, we want the same water, we want the same soil, nutrients, etc. Everything else needs to stay the same, so that the only thing that we can determine that's affecting our final end result, which is our dependent variable, okay, would only be the independent variable. So all of these things that stay the same, we call them constants. And you need to be able to look at an experiment and determine if they actually kept the experiment constant in everything except for the independent variable. So if they did not, then you could say they had too many variables, that instead of keeping the light the same, they kept changing the light or whatever. So you have to be able to analyze that. So this week you have a couple of questions where you're going to have to analyze an experiment and tell me what they did right and what they did wrong and how you would change it, okay? So all of this is good, and then we have our last little factor called our control. Now the control is the situation or normal scenario for whatever you're testing. So in this lab, I told you we're going to test different temperatures, okay? So in this lab, the control would be the one that is at the normal temperature, okay? Whatever the temperature is of that organism. If we were testing different amounts of sunlight, then our control would be the one that had the normal amount of sunlight, and then we would manipulate all the different sunlights. If we were testing the amount of salt and how the amount of salt affects different plants, then our control would be the one with no salt. So your control is completely dependent upon the type of experiment that you are doing. On the experiment is that you have to be able to know where to graph it. Okay, so on a graph, this is our x-axis and this is our y-axis. Whatever you put down here, if it increases or decreases at a predictable rate, they have to be separated equally. And the same thing here. Okay, now you're not going to have to graph this year, but you may have to make a graph to analyze some things. I don't know. So on your x-axis is where you put your independent variable, unless time is one of your variables, and we'll be working on that this week. But your independent variable would go there, and then over here, this is your dependent variable. Okay, and so lots of times there's units with that, right? So this would go up, and you typically want to start at 0. A good graph doesn't start randomly. So, and then line is if it's a change over time, or if we're doing molarity, if we're looking at how molarity increases, what happens to the cell, or if it's pH increasing. Anytime there's a scale of things that can increase or decrease, you're going to use a line graph. But there's going to be a bar graph if you're showing comparisons, overall comparisons of things.